Alright, y'all, today we're going to be talking about Pascal's triangle. It's section 10.2. We're actually just beginning this section. There's going to be 2 parts. And today you're going to need a calculator and a note card for a little bit later. For these very first ones, it doesn't really seem like this stuff has anything to do with this chapter because this is some expanding binomials, some algebra, whereas we've been talking about probability all chapter. Next class, I'm going to show you how this actually directly relates to that probability. Okay, for now, we're just going to remind ourselves of these powers and their meaning. Ignore that big mess up there. We'll talk about it here after a while. When we're taking something to the 0 power, remember that is 1 by definition. Anything to the first power gets to be itself. And after that, you just have to think about whatever you're taking to a power. So this one we want to square x plus y. That really means we're taking x plus y and writing it twice or multiplying it by itself. And for that, we have to FOIL. So anything past that 2, we got to work out that way. First term times first term is x squared here. Then our outside is xy, and the inside is yx. Okay, when we're talking about expanding these things, when we look at xy and yx, they have the same variables with the same power. These are exactly the same, they just are written differently. We're not going to write them differently. Okay, so if you keep x first all the way through, that's going to help us here. So this says xy, this would also say xy, meaning plus 2xy. Then last times last is y squared. Alright, this third power just means we're going to do this x plus y 3 times. We've already multiplied 2 of them together, so this part comes down. X squared plus 2xy plus y squared. And we're going to just tack on one more of these things, x plus y. So we're less experienced when we have products of polynomials that have more than 2 terms. So this time we've got a 3-term polynomial and a binomial, or 2 terms. So 3 times 2 gives us 6. When we distribute this out, we're going to end up with 6 terms to start out with. So here's how I want you to do these. It'll keep our like terms together most times. We're going to take this first term, x squared, and multiply it by everything over here first. So x squared times x is x cubed. Then we're going to take the same x squared and multiply it by the second term. So that would look like x squared smushed with y. Then we're going to go and do the next term over here and do the same thing. It gets multiplied by both x and y. So starting out with 2, this x and x makes x squared, and the y goes just to the end. Then we do the same term with y. So plus 2x, this time the y goes up by 1. And then finally, we're doing the same thing with this last one, putting that on both. But remember, we're going to keep our x first here, so we're going to write x and then the y squared for this one. And finally, y cubed for the last term. But as we're FOILing these out, we're going to end up with some like terms or things that we can combine just like we did up with the last one. So the x cubed, there's only one of, nothing else we can combine it with. But here, side by side, we've got like terms because remember, the powers just have to match. So this says 1x squared y plus 2x squared y. We just combine our coefficients and get 3x squared y. Same thing over there on the next 2. We've got plus 3. This time we've got xy squared. And we're ending up with our plus y cubed. So what I'm going to have you do is on the next one, expand out this x plus y to the 4th power. Okay, bring down what you just got and tack on x plus y one more time and FOIL that out for me. Okay, we've got 4 terms times 2, so you should have 8 when you're done. Pause the video, take care of that for me. As you finish here, your final answer should look like x to the 4th plus 4x cubed with a y, then plus 6x squared with a y squared, then plus 4x with y cubed, and finally y to the 4th power. And I'm able to do this because all of these things that we've been talking about have a special pattern. Okay, I didn't actually FOIL that out. I just knew that was the way the answer was supposed to look. Because here's what's happening. This first power is 4. The last power is 4. And all of the middle ones add up to 4. We've got 3 and 1, 2 and 2, 3 and 1. And the pattern with the x's is special as well. You'll notice x goes from the 4th power to the 3rd to the 2nd, 1st, and this one doesn't have any at all, or 0. Same thing happens with the y's, 4, 3, 2, 1, 0, going backwards. So then the only thing that we have to figure out is where these numbers came from in terms of the shortcut, because there is a shortcut for it as well. So the next thing we're going to do is actually dealing with the note card that I was telling you about. So if you have one, grab it. If not, you need a piece of scratch paper. And what we're going to do on this piece of scratch paper is start with the title, 10-2 Pascal's triangle, and then down the side, 0 through 10. In the middle of row 0, go over and put a number 1. Okay, pause the video until you get that taken care of. Now we're going to talk about what to do to make our triangle. We're going to have a triangle on here that's formed by different numbers. So each row that we go through here are going to have extra numbers so that we end up making this triangle shape. The first row after 1 here is 1 and 1 because the sides of our triangle are going to be 1s all the way down. The middles of our triangle come from what's happening above it. Okay, so the side I am starting with 1, but then the middle terms are going to be the sum of whatever's above it. So 1 plus 1 is 2, and then now I'm back to the side is 1. The next row I'm starting with a 1. This time I have 2 terms in the middle. So between these 2 numbers, 1 and 2 is 3. Between these 2 numbers, 3 again, and 1. So each time I'm just increasing by 1 extra number, and I'm going to continue this pattern. So we'll do one more together. 1 and 3 is 4. 3 and 3 is 6. 3 and 1 is 4. And you're ending with a 1 for everyone. Okay, so pause the video and do all of those. Okay, grab a calculator if you need to, because if you mess up somewhere, all of the numbers after that are going to be wrong. So be careful as you finish out that note card. All right, when you're done, this is how it should look. Just check this bottom row. If the bottom row matches, then everything else does. Okay, but what I was telling you is this was dealing with what we were just talking about, those numbers in front, or the coefficients. If you compare this triangle to our first 5 problems, you'll notice that a pattern is happening. The first one had 1. The second one, coefficients were 1. Then I had 1, 2, 1. Then I had 1, 3, 3, 1. And 1, 4, 6, 4, 1. And those are just the numbers from this triangle. That's going to happen every time we take some binomial, 2 terms, to a power, where the power represents the row that you go here. That's why we started at 0 instead of starting at 1, so those powers can directly match. All right, so what we're going to do on the next one is apply this rule instead of taking the time to FOIL everything out. Okay, so remember, the first thing that's important is knowing those coefficients, and that comes from the row you're looking at. Okay, so you are on row 5 from that triangle that you just made, and that's 1, 5, 10, 10, 5, 1. There's always one number more than your power, and your power is always the first number after 1. Okay, and here's how it works. Your first variable is going to start at the highest power, so this looks like 1x to the 5th, and the combination of your variables should add up to that power of 5. So that means I can't have y at all on this one, because I'm already at 5. Then the next one, 5 comes down, and I'm decreasing by 1. So this one would be 4, and I need my powers to add to 5, so that has to go with 1. The next one would be 10. I'm starting at 3 for this one, and that makes y have to have a power of 2. And then the next one, 10 again. Continuing that pattern would be 2 for x and 3 for y. And then 5xy to the 4th. And finally, on this one, x goes to 0, you don't have to write it. In fact, if you do write it to start with, you have to end up crossing that out because remember, anything to the power of 0 is 1. So this ends up being the y to the 5th. So just leave that off. All right. But we're not only going to talk about problems that are just x and y, we're going to talk about any binomial. So the process changes just a little bit for these next ones because you'll notice our terms can involve numbers or it can involve numbers and variables together. So we're going to practice a process that works for every single one, not just the ones that look like x and y. Okay, so first process is the same right down the row. So this is 1, 3, 3, 1. Okay, from there, here's how I want you to do it, which is a little bit different than what we did last time. You're still going to start with the number 1, but instead of filling these in to start with, I want you 2 parentheses next to each other. And then you put the v in the first one and the 2 in the second one, and we're going to come back to powers. Okay, then go to the next one, 3. Again, 2 parentheses next to each other. V goes in the first one, and 2 goes in the second one. Okay, then our next term, V and 2 again, all the way through. So then, when we go through here, we're starting with our highest power on the first one. This would be 3, and we're just going to decrease each time on that same V. At the end, we're going to go backwards. We're still starting at 3, but then we're decreasing going the other direction. And this makes sure that we don't get the 0 part wrong on what it goes with, and we don't forget it entirely. We don't start at 1 instead of starting at 0. Okay, we can always double check ourselves by making sure that the powers are always adding to 3. Then we go simplify. This says v cubed times 1. Over here we've got multiple numbers. I know I'm going to have v squared, but I have to have a number in front, and some of these numbers are going to be raised to exponents, so we have to make sure to pay attention to order of operations. We're starting with 2 to the first. 2 to the first is 2, then multiplied by 3 gives us 6. V squared tacked on the end. Over here, I know I'm going to have v. We're going to start with our numbers. 2 squared is 4, times 3 is 12. And then last one, the v went away completely. It was just 2 to the third times 1. This part's 8 times 1 stays 8, and that is it. A little bit more work than the last one, but still faster than writing this thing 3 times and foiling it out. Okay, this one we see a couple new things. We've got numbers in both pieces now, and we see a minus in the middle. First step stays the same. We're writing the row. So find the 5th row and write it down for me. Okay, from there, we're going to do the process the same as the last one. The first number from here, 2 sets of parentheses. I know my second one has to be a little bit bigger. Okay, and then the first number gets to be 1. The second gets to be actually a negative 2q. So the sign matters. It has to go with it. We didn't need it on the last one because it was positive. Okay, then we're going to go all the way through here following that same process. 5, 1, negative 2q, plus 10, 1, negative 2q, plus 10 again, 1, negative 2q. And then we're seeing some symmetry, some repeated stuff. And then we'll attach our powers. Our powers start at 5, so we're starting at 5, 4, 3, 2, 1, 0 outside of those. And you do have to write 0, because remember, if you leave it off, that really means 1. So write that out. Then going backwards, we're at 5, 4, 3, 2, 1, 0. Doing a quick double check that all of our powers add up to 5, and then just crossing out the stuff with zeros. From here, we're going to simplify. We know 1 to any power is 1. So this thing is just the number 1 because Q crossed out entirely. Okay, but here's the first time we get to see 3 pieces with numbers involved. Okay, exponents have to happen first. So this 5 is really the last thing we're taking into consideration. That's why I kind of work backwards here. Negative 2 to the first is negative 2. Times 1, still negative 2. Times 5 is negative 10. Then the Q to the first goes on the side. Now, these ones aren't so bad because part of my term here is with a 1, but in general, these can get kind of messy with order of operations, so I'm going to show you how to use your calculator for this as well. Okay, so we're doing this next one in our calculator, even though we could probably do it in our brain. So with this one, we are starting out with the number 10. As long as we're using parentheses, we can go front to back because our calculator will understand the order of operations. So then we're doing 1. Again, I wouldn't ever type 1 to a power in the calculator because that's just going to be 1. Okay, but in general, here's how it works. You're going to take the parentheses you see, you're just going to leave out that variable. And then that tells us our final answer for that piece should be 40. So we are saying plus 40 since it was positive, and then throwing the variable on the end, Q squared. Same thing goes for the next one. We'll type this in, starting with the 10, then our 1 squared, and our negative 2 gets raised to the third power. And we're at negative 80. Okay, go ahead and type in those last 2 for me. We'll see when we work through these a pattern of alternating signs. We've got a positive, then we've got a negative, then a positive, and then a negative. So this one, just by using that pattern, should be plus. I know this has to be Q to the 4th power, and this one ended up being 80 again. Okay, last term, negative 2 to the 5th is a negative number, and it's 32 with Q to the 5th. Okay, so when we're looking at these, I want you to always check out your final answer, make sure your powers follow the pattern that they're supposed to, and that if you have a negative in the middle, you see alternations going on. All right, we're going to do this next one, making sure we can do it when ones aren't involved, but other than that, it's very similar to the same process. Okay, we're starting with the row we need, 1, 4, 6, 4, 1. And then we are filling it out. 4A goes first, then 5B. This one's positive, so no worries about the negative. Then 4, 4A, 5B. 6, 4A, 5B, all the way through here. Then we attach our powers, starting with the highest. Our highest is 4. So 4, 3, 2, 1, 0. And backwards, 4, 3, 2, 1, 0. All our powers add up, so we're good there. We're getting rid of the zeros and typing stuff in. 4 to the 4th is 256, which if you don't know, you just throw in your calculator. But starting with this one is what I wanted to show you with your calculator because it's got multiple pieces here. Okay, same process, but we do have to type in all 3 pieces here, leaving off the variables for both sides. So we're starting with 4, and then our parentheses. 4 gets raised to the power of 3. Exponents should always be outside your grouping symbols. And then the next one, 5 gets raised to the 1st power, so we've got 1280. when we're putting on our variables, we have to pay attention to both. A goes to the third power, and B goes to the first power. Okay, we're not allowed to do these separately. Okay, for this one, if we see a problem like 5a, 5b, just using smaller numbers here, okay, this isn't proper. We don't want numbers in the middle. Coefficients can be grouped together. When they're smushed, it's just multiplied. We want to call it the best possible version and put those together in the front. That's what's going on here. Variables will be smushed at the very end. Okay, with that process in mind, you should be able to finish this problem. Pause the video and take care of that for me. Alright, this one should have been 2400 a squared and then b squared, just looking at those. Okay, over here we had 2000 a b cubed, and then 5 to the fourth is 625, b to the fourth because a disappeared. Okay, all positive because our sign in the middle was. Number 10, I want you to try all on your own from beginning to end. Okay, pause the video, take care of that, and I'll show you what your answer should look like when you're done. Alright, here it is. We had a negative inside, so we have alternating signs all the way through. Checking the powers, they should be 4 all the way through as well. The last thing we're going to do today is talk about when it doesn't ask you for the full expansion and it only asks you for part of it. Okay, so what we can do on these, instead of taking time to write out all of it, if I only care about one term, then we're just going to focus on that one single term. So process starts out the same. We're looking at the row we need and writing it down. 1, 5, 10, 10, 5, 1. Okay, and then from there, we are finding the one that would match up with this, and you really only have to pay attention to one of these. This first term would go x to the 5th power, because I know that's my highest. The second one would go x to the 4th, and then x cubed and x squared. I know that these add up to 5, so that ties in with the y cubed, but this is the one I'm going to use to expand out just that one piece. So starting out with 10, and then doing the same process that we did on the last one. 2x goes first, 5y goes second, but we already know what our powers are supposed to be because that part was given to us. 2 goes first, 3 goes second. Okay, so we're typing that into our calculator. Again, the same process we've been doing before. Start out with your number in front. As long as you use parentheses, that's fair game. To get 5,000. Okay, let's pay attention to the question here. It says just the coefficient. So I know my term would end up looking like 5,000 x squared y cubed, but it just wants the number in front for this one. Okay, that same thing is happening on this problem, so I want you to pause the video and take care of that one for me. Okay, find the coefficient on Pascal's triangle that goes with v squared and expand it out to find the answer for number 12. Number 13 is a little bit different because it actually is asking for the term. Okay, so for these ones, we're still going to Pascal's triangle, okay, but we're just looking for the middle term. Now, generally, I want you to write out the row, but this one, we can find out the coefficient that's needed automatically, because when we're talking about this problem, we already know the middle is the middle number from our row, and there were 7 numbers. The middle number is 20 there. We don't have to pay attention to exponents and write it out. Okay, it's just looking for the middle number in the 6th row. Okay? With that in mind, we still have to set up the process like last time. The 3x goes there, the 5y goes here, but it wants the whole term, so we have to make sure we're putting powers attached to this as well. Okay? If we think about it, we know that the middle term goes with the middle power. halfway of 6 is 3, but you can find that same thing by counting them out. 6th power, 5th power, 4th power. That middle term is the 3rd power, and that'll fall through that way. And then we just expand it. Okay, so again, in our calculator, but for this one, we do want our final answer to have variables attached to it. So when we do this, we'll tack on our x cubed and y cubed to finish up. So this one's is 67,500 x cubed, y cubed, and this one works the same way. Right? When you're doing your homework, make sure you take the time to work these out. The answer key will have the answers, but they will not have the work. Okay, I've got to see that for you to get credit on this homework. Come see me if you need help, but you have to practice these. I know it seems monotonous and tiresome, but these are worth quite a few points on quizzes and tests, and you got to know what you're doing.